go. All right, so we have solving equations by factoring. We're going to stick in that fancy word, which is fourth degree, and the fancy word for fourth degree is quartic. Okay? Fourth degree. All right, so that's what we're going to be talking about today, and I tried as best I could, Aaron, to give us a kind of a formula there in terms of process. I apologize if it's not perfect, but we'll try to walk us through it. First of all, whenever you're starting, Catherine, you're always going to look for a GCF. Look for an X in all of them, look for a 2 in all of them. That's just a standard without saying we're always going to look for a GCF. And if it's there, we're going to factor it out and drive it. I'm not going to say we're going to see those today, but we're always going to start by looking for them. So I look at this first one, x to the fourth, 7x squared, and 6. There's no common x, there's no common 2, so there's no GCF. But we want to look for it. And I don't want to dismiss the fact that I am always in the back of my mind looking for that. It's like when you're driving on the road. You're not expecting someone to run out from behind a car, but you should always be looking for it and anticipating it when you're going through a short residential area. I think when I'm driving home past a soccer field with all these cars parked, and occasionally a kid will dart across the street because they're running to their car to get their gloves or get their whatever for their soccer game. So, next, is the equation a quadratic type? Is it something squared plus something plus a number? And so what we do is we look at this problem. And I say, you know what, this is kind of a quadratic type. It's something squared plus 7 times something plus 6. Now what that squared thing is you look at the middle term. And the middle term typically is a clue to tell us what the item being squared is. And so the item being squared here is x squared. Because would you agree that x squared is x to the fourth? All right, and that's what we know, how we identify what that quadratic-like problem is. And so we have x squared squared plus 7x squared plus 6. And now we just are going to factor it just like normal. And here we go. If this is a plus and a plus, we know that's a plus and a plus. Normal factoring goes. Tell me, what multiplies to 6? 1 and 6, 2 and 3. Which of those combine to 7? 1 and 6. Now, what are we squaring? X squared. And so we put an x squared in the front and an x squared in the back. And let's see if this works. We get 1x squared, 6x squared, that makes 7x squared. X squared times x squared is x to the fourth, and 1 times 6 is 6. Now we say, can we go further? Well, here we have the sum of 2 squares. And in our kickoff intro, we reminded ourselves this morning that the sum of 2 squares, what? Does not factor. And then we have x squared plus 6, and that once again is the sum of 2 squares. And so that does not factor. So we're done. Okay, so it's just recognizing that this is very similar, Noah, to a quadratic equation. We're just making it to the power of 4. That's all. Make sense? Don't want to belabor this, don't want to make it fancier than it is. It's really quite simple.
So it doesn't matter that the 6 doesn't have an x, you can still take out the x.
Right. Because this is really just like a problem had we had this. A squared plus 7a plus 6, and that would have factored to a plus 6 and a plus 1. And our a, supposedly, Aaron, in this case is x squared.
Okay.
That's all. And if you saw this red one, you would have no problem with that, true? And so this is just jumping it up, ramping it up one level, because in Algebra 1 we did basic factoring, and now we're kind of talking about, okay, what about all the other possibilities? So, all right, so let's take a look. So here is the equation, a quadratic type. In other words, is it something like x squared squared plus some number times x squared plus a number? And then from 4 down, really, it's about solving. We would set each factor to 0, solve each one, and there will be as many solutions as there is degree. And Simon, just as a review, the degree on this is 4. So there would be 4 potential answers. They might be imaginary, they might be real. Remember, a real number, guys, crosses the x-axis. An imaginary number does not. All right, going down to our second one. X to the fourth minus 3x squared minus 10. Focus in on the middle right here. That's what's being squared. So put that in the front. Is x squared squared x to the fourth? And then in parentheses in the middle we have x squared. Okay. My signs. I need to get a minus 10. Remind me, what are my signs? Plus and minus. Okay. Plus and minus. I need to get a 10. So 1 and 10, 5 and 2. I need to combine them to get a negative 3. Talk to me. 5 and 2. Is it going to be a plus 5 and a minus 2, or a minus 5 and a plus 2? Minus 5 plus 2, because that gets us the negative 3. And then in the front goes my x squareds. The first one doesn't factor because it's the sum of squares. The back one, if it was x squared minus 9, could that go further? Yeah, x plus 3, x minus 3. But here, because 5 is not a perfect square, you can't go any further. That's all. So you're done. Questions? So once again, if you ended up with this, x squared plus 2, x squared minus 9 as the middle step, then your final step would be like so. X plus 3, x minus 3. So you would go further then, and the only time that's going to happen, Christian, is when this back number is a perfect square. 9, 16, 4, 1, something like that. But in many cases, we might stop at this level right there. So if you're going to go further, this has to be the difference of two squares. We good there? You might bump into one in the homework. I don't know if there's there or not. I didn't work every single one out. I just am trying to give you some general overall guidelines. Okay, let's shift to the back page. And now the big difference is on the front page, we had factoring. On the back page, what are the direct instructions? Solve. Ideally, when we're solving, we have to be equal to 0. So let's get this equal to 0. The 18 changes sides, so it's going to also change signs. So it becomes a positive. And I need you to realize there are 4 potential solutions. 4 potential solutions. They may not all cross the x-axis, but there are 4. Catherine? Thank you. Thank you. I'm so used to quadratics that I forget sometimes when it's a quartic. All right, so let's write this down. Parentheses squared plus 11 times parentheses plus 18 equals 0. Once again, what goes in the parentheses is my x squared, and there we are. Tell me, if you would, what multiplies to 18? 2 and 9. What else? 6 and 3. Which of those combine to 11? 2 and 9. What are my signs? Plus and plus. And what goes in the front of each one? X squared. Well, now it's equal to 0. So now we have to finish it. We have to actually give answers, Haley. And so to give answers, we're going to take each of these factors, break them up by the zero product property, remember, and one equals 0 and the other equals 0, and solve. Now remember, how many solutions should we have? 4. So here we go. First one, x squared plus 2 equals 0, and x squared plus 9 equals 0. So x squared equals negative 2. X squared equals negative 9. Do what to both sides? We take the square root of both sides, and when you take 2 square roots, you have what? 2 answers. Remember this? 2 square roots, two answers. And so we're going to put square roots over both sides. And when I do that, remember, what do you have? Plus or minus, right? Plus or minus. The negative comes out. I heard Simon, you say I, and the root 2 stays there. So tell me, are those graphs, is that crossing the x-axis? Because they're imaginary. If it was just plus or minus square root of 2, it would. But here it's an I, so Paul, that means it doesn't cross the x-axis. Over here, we take the square root of both sides. Remember, 2 square roots, 2 answers. What president? Nixon. All right, so x equals plus or minus, what's the square root of negative 9? 3i. How many answers do we have? We have 4, right? Plus I root 2, minus I root 2, plus 3i, and minus 3i. Someone asked me 6th hour the other day, can you leave them as plus or as minuses? Yes, you can. And so we would just write down our answers in a solution set and realize we've written down 4 answers there. None of them cross the x-axis. None of them. And by the way, this is the shape of a W, and the whole W is going to be above the x-axis. So just imagine a little W up there, and the whole thing's above the x-axis. And the way you know that, Christian, is that none of them are real numbers. They're all imaginary. And when you have imaginary numbers, that means there's just a squiggle in the air, and it doesn't cross the x-axis. Okay? Really, is there much new there? It's just kind of bringing all these pieces together from what we did first semester and back in Algebra 1 to go from there. All right, our final. Here we go. What do you think we should do first?
Divide out a 3.
Divide out a 3.
Or actually, you should subtract 15.
Bring the 15 first? Okay. I don't think it really matters, Simon, but I do like to combine everything first to make it better. So we bring over the 15, and I believe we get 135 negative.
Yeah.
Okay?
Why is it subtract 15?
Because it's a positive 15 here, and so to bring it over, we have to minus it. Good question. All right, second thing, I think you're right. We divide everything by 3. Now, does anyone know the trick to know if a number divides by 3? Max, you remember it?
Isn't you add all the numbers up and
Uh-huh.
it's a multiple of 3?
All right, so like 1 plus 2 is 3. That divides by 3, so 12 divides by 3. That's easy in our heads. But what about this big one? 1 plus 3 is 4. 4 plus 5 is 9. Is 9 divisible by 3? Therefore, 135 is divisible by 3. So let's do that. Let's divide everything by 3. So that's x to the 4th. 4x squared. 3 into 135.
45.
45. 0 divided by 3? 0. Where's the 3? It's not there anymore. Had we been up here in the factoring section, you can't just divide by 3. You have to factor it out, right? And it would just carry along in the front. But because we're in the solving, we don't have to deal with it anymore, and we go from there. All right, so parentheses squared minus 4 times parentheses minus 45 equals 0. I'm going to circle my x squared. I'm assuming by now you guys are getting the hang of this. So we have parentheses equals 0, x squared and x squared, plus and minus, multiples of 45, 15 and 3, does that work? That gets you 12. What else do we have? 5 and 9. That gets us a 4. Which one wants to be negative? Which one's positive? Negative 9. That means it's a positive 5. There we go. There's my factors. So x squared plus 5 equals 0. X squared minus 9 equals 0. I'm going to do the easy one first. X squared equals 9. Square root of both sides. X equals plus or minus 3. Over here, x squared equals negative 5. Square root of both sides. x equals plus or minus how much? I root 5. Oops, that's not neat. I root 5. Show that whole problem there. Questions? I feel like a lot of this is a culmination of a lot of different little pieces that we've been working on in these little sections. And now we're bringing things together kind of as a whole offensive play. You know, first we worked on the receivers and then the quarterback and then the centers and then all the different picks and the screens. And now we're kind of all together, we're figuring out what this is going to look like. Question, does this W cross the x-axis? Trivia. Does it cross? Max, you're saying yes.
Yeah.
I agree. Why?
Because 3, there's no, it's not magnitude.
Yeah. These right here, because those are real numbers, it does cross.
Why is there a negative 5 in the square? Like, how did you get negative 5?
I subtracted 5 from both sides and brought the 5 over.
Oh.
I remember a little rhyme in my head. If a number changes sides, it changes signs. That's my little idiom there. Okay, well that brings it up. That's it. So.